Good morning, everyone. Welcome to part 5 of Area of Polygons. I know this section of chapter 6 is quite long, but we are almost over with area. Just one more lesson after this. Now today we're going to actually be talking about area of composite shapes, and what that essentially means is we're going to be looking at complex shapes that are made up from simpler ones like rectangles, triangles, and all the other ones that we saw in the previous sections. Alright, so let's actually start with our first example, and you'll know exactly what I mean by this. So here we are, we have a L looking shape, right? That's clearly made out of two different rectangles. Now you'll notice that over here we have a 2 kilometer section, right, from here to here, and we know that this part is the same length because we have those lines, right? Whenever you have lines like this, they're simply telling you that they are the same length. Okay, so we actually have all the information that we need to calculate the entire area of this L shape. What we need to do though is simply break it down. So I'll do this right now by jotting a little line like so, right? We've broken it up into its two smaller parts. And now we're actually going to do our calculations. I'm going to start with the rectangle on the bottom, but it's up to you where you want to start. You could have done the rectangle at the top. It makes no difference. So let's start with our solution. Like I said, I'm going to start with the area of the bottom rectangle. So I write my equation. Since we're working with rectangles, it's simply base times height. I plug in my numbers, which is 10.5 and 2, right? 10.5 being my base and 2 kilometers being my height of this rectangle. And then I calculate to get an area of 21 kilometers squared. All right, so let's do the area of the top portion. So again, same equation because it is the same shape, just a slightly different measurements. Okay, so let's plug in our numbers. We have 2. Remember, this is the same length as up here, so that's where my base of 2 is coming from. And we are told right on the diagram that our height is 4.3 kilometers. So let's calculate that. And we get an area of 8.6 kilometers squared. Now our last step in all of these problems is to actually add these up. We're looking for total area, right? So again, area of the total shape is equal to my first area plus my second area, and we get an answer of 29.6 kilometers squared for this example. All right, so you'll see some where the shapes are actually merged like this, and you'll see some that are less merged, like our next example. So here we have kind of a Christmas tree looking thing, or a pine tree. No Christmas decorations on it, so I guess just a pine tree. All right, so there is a lot to look at over here. There's a lot of arrows, there's a lot of measurements. Let's break it down very simply. So you'll notice that this section from this point to this edge is 0.65 meters, and we have the same thing on the other side. And then this, I guess the tree trunk here, the width would be 0.45 meters. Okay, so if we add all of this together, right, we would get the actual base of my triangle. So that's where we're going to find our base. Now height-wise, we already know for the triangle. So once we realize that this can be added up for the base, we have our height, we can do the calculations for area. The rectangle, when we get to that, you'll notice that yes, very easy. Our base is given right here, but for height we'll have to do a small little calculation in our head. So essentially, if we know the whole thing is 2.05 meters and we know this section is 1.25, we're going to have to subtract this part from here to get my height. Okay, so we'll do that as we go along through the solution. So I'm going to start with the area of the triangle. Again, you could have started with the rectangle. Does not make a difference. Don't forget that the area of a triangle, we have a division by 2. Some students tend to forget that and just do base times height. But remember, a triangle is essentially a rectangle that's cut into 2. So we plug in our numbers. Like I said, 1.25 is given to us for our height, and 1.75 is what we get when we add these 3 numbers up. Remember that they would make up this side here, or our base. And we get an answer of 1.09 meters squared for the area of our green triangle. All right, so let's move on to the area of the rectangle. We do base times height, no division by 2 because it is a rectangle. It's as easy as can be. Plug in our numbers. Again, 0.45 is clearly identified over here. The 0.8 or 0.80 is what we get when we subtract 1.25 from 2.05. All right, so that's how I got the actual remainder here. And then when I actually punch that into the calculator, I get an area of 0.36 meters squared. And of course, my last step, finding the total area. Let's add everything up. Total area is equal to the green portion plus the brown portion. Plug in our numbers, and we get an answer of 1.45 meters squared. So a lot of these questions are, again, going to follow the same type of pattern. You always find one shape, second shape, third shape, fourth shape, fifth shape, depending on how complex the composite figure is. And then, of course, your last step is always to give the total area. So let's take an example where we have more than two shapes. Here we go. So we do have a square over here. We know it is a square because there are lines here identifying that all sides are equal. Of course, we don't have one here, but because there's 3 out of 4, we can assume over here it's the same thing. And then I identify here a rectangle and then a triangle. So to make us see it more easily, let's put some dotted lines here. So that's where my square is, and that's where my rectangle is, and of course my triangle is left over. So let's do our calculations. We're going to start with the easiest part, the area of the square, right? We only need one measurement since all the sides are equal. This is the equation we're going to use, of course. S squared, 4 squared gives us 16 meters squared for area. Right, so that's the easier one. Let's move on to our rectangle. So here you might notice, well, I know my height. My height is 5 meters. That's clearly identified. But what about my length, or what about my base? I don't actually have that. Well, if you look closely, you can actually see that this 6 plus this 4, right? Because this is the same size. This is the same length. Well, if we add those two, that's going to give me the base of my rectangle, and we get 10, of course. So start with your equation and then plug in your numbers, and you get an answer of 50 meters squared. All right, let's move on to the more complex shape, the triangle. So of course, the equation again is base times height divided by 2. Plug in your numbers. We know that the base here, right, if we're going to use this as base, since it is perpendicular to the height, we're going to use 10 again because it's the same length as this side. And then the height, of course, is 7 meters. That's clearly identified for us. Plug in our numbers. We get 70 divided by 2, which gives us a final answer of 45 meters squared for the area of that triangle. Now our very last step, step number 4, is to find the total area again. So add up all the areas that we found before, plug in your numbers, and you get an answer of 111 meters squared. All right, so you're going to see a lot of different problems in the workbook. Please go through the homework. If you have any difficulty, of course, you can always ask me on Zoom. I'll do maybe 1 or 2 examples in class. And yeah, that's about it, guys. I'll see you in a bit. Bye.